this is what we're talking about now. Tomorrow we will finish this, and next week we will start talking about how matter changes. We will cook some things at home, we'll burn some things, we'll change matter from solids to liquids to gases. So next week is how matter changes. So today is the last week for talking about properties of matter. All right, today I need someone to read this. Let's start with Mia, number 1, starting with today.
Today we will review mass, classify solids, liquids, and gases.
Excellent. First, we will review. Number 2, today we will.
Today we will learn a new property, volume.
Good. That word is volume. We're going to learn about a new property today, volume. Number 3, starting with today, Nick.
Today we will learn how mass helps us classify matter.
Very good. How can we use the property mass to help us classify into groups? And number 4, let's have Susie.
Learn how volume helps us classify matter.
Very good. Okay, then we're going to look at how volume helps us. So this is our plan for today. You will go over your homework with Miss Hun in your next class, okay? The first thing we're doing today, review mass, classify solids, liquids, and gases. Can you please read the orange box for me? Lily, please read the orange box.
Property, mass. More matter equals more mass.
Very good. So what would have more mass? Lily, me, or the water bottle? Remember, matter is anything that takes up space. Solids, liquids, and gases. What has more matter, me or the water bottle?
Miss Miranda.
Yes, Miss Miranda, me. So what has more mass, me or the water bottle?
You.
Exactly. I have more matter, so I have more mass. I need someone to read the first and last sentence for me only. So I need sentence number 1 and then the last sentence. Let's see who can follow that direction. That's very specific. Let's have Lion go ahead and read for us.
Mass is a amount of matter in an object. You can use grams to measure the mass of an object.
Very good. So the same way we use a ruler to measure how long something is in centimeters, we can use a balance to measure the mass of an object. So who can tell me which side of the balance has more mass? The side that goes down or the side that goes up? Which one will have more mass? John, which side will have more mass? The side that goes up or the side that goes down?
Side that goes down
Will have
more mass.
Excellent, because it's heavier, it has more matter. So everyone, please circle the side that has less matter. Which side has less matter? All right, now I want you to draw an X over the side with less mass. Which side has less mass? Draw an X over the side with less mass. Nice. The same, right? Less matter, less mass. Balance. It compares the mass of two objects. Which one has more mass? Who can tell me? Can a balance give you the weight in kilograms, for example? Can it tell you how much something weighs? Leo, what do you think?
No,
Why?
because it only compare the mass and it compare which one is have more mass and more matter. It is not.
Exactly, you are exactly right. It just says which one has more mass or matter. It can't tell us how much more, right? It might say, well, this one's heavier, but it could be 1 kilogram heavier or 50 kilograms heavier. It can't tell us. So a balance compares the mass of two objects. There is another thing called a scale. A scale tells us the weight in grams or kilograms. The scale will tell you the weight. The balance only compares the mass. Are there any questions about how a balance is used to compare the mass? All right, and what can tell you the weight? What can actually tell you the mass of an object? What tool can tell you the actual mass of an object? Thomas?
A scale.
Excellent. Can you say a full sentence, please?
A scale can tell the total mass of an object.
Excellent. Using grams or kilograms. You guys are doing amazing on this review. I'm very impressed. Compare the mass of some things in your house. Everybody pick 2 things off your desk. Let's compare them. Who wants to go first? Riku. Oh, Riku ran away though. Riku, go ahead and hold your 2 things up for us.
This one is my book and this one is my pen.
All right, go ahead and pretend you are a balance and show us which one has more mass.
This one made by paper, so it's not heavy. This one made by iron, so it's heavy.
Excellent. So which one has more matter? The book or the pen?
Pen.
Excellent. Nice work, Riku. First one. That was amazing. All right, who else would like to share about their mass or matter? Let's have Jack. Jack, go ahead and hold them up for us.
This book is made from paper, so it will be lighter. And this made from iron, so it will be heavier.
Okay, so which one has more mass?
This.
Nice. Excellent job. All right, let's have another one. Who else would like to go? Robert, go ahead and show us your 2 objects and show us your balance.
Here is my magnifying glass, and here is my iPad. And the iPad is heavier.
So which one has more matter, the iPad or the magnifying glass?
The iPad
has
more matter.
And
Mass.
Nice. Excellent work, Robert. Good job. Okay, guys, that's all we have time for that one, but don't worry, we'll be doing this again. All right, classify. Everybody, please say the word categories.
Categories.
Good. Categories is the same thing as groups or classes, the same thing. And characteristics and properties are very similar. Characteristics and properties are very similar, kind of like traits. So categories is very similar to groups. Characteristics is very similar to properties. Everyone, go ahead and read that paragraph, starting with the word classify. 1, 2, 3.
Classify. Some people are
Very good. Excellent work. So, how do scientists classify matter? Who can tell me, how do scientists classify matter? Kat, what do you think, Kat? How do scientists classify matter?
They use matter and property.
Very good. They use properties to classify matter. What?
I have another.
Go ahead, Potato. What's your other answer?
The scientists combine solid, liquid, and gases.
Very good. So they use the properties to classify matter into solids, liquids, and gases. Do you guys classify anything in your house? Who could tell me an example of something you classify in your home? Susie?
I can classify pens.
How do you classify them? What property do you use at home to classify your pens?
I use size.
Nice, excellent. Very good, Susie. Who else could tell me something you classify? Dragon, nice and loud. Classify, let's say it one more time then. Who could tell us what classify means? Alex, do you know what classify means? Could you explain for Dragon?
Classify means compare something.
To compare something and then do what? Put them in
Groups.
Very good. So we compare things and put them in groups based on how they are the same. Like scientists compare matter and put them into groups based on how they're the same. Solids all keep their shape. Liquids take the shape of their container. Gases have no shape. Okay? So, who else can tell me something you classify at home? Nick.
I classify action figures.
Action figures. How do you classify your action figures, Nick? What properties do you use to put them in groups?
Sizes.
Full sentence.
I classify it by compare it with sizes.
Excellent. Nice work, Nick. Let's have one more person who would like to share how they classify something at home. Mia, go ahead, Mia.
I classify books
By
shape.
By shape. Okay, very cool. Nice work, everybody. Let's get some practice in here. Everyone's ready to draw. Go ahead and draw your lines. Please, no scribbling. Nice straight lines only. All right. Who can read solids for me? Let's have Ben. Ben, can you please read the one for solids?
Keep the shape of its container.
No, not that. Oh, I see. We have two sets of lines going for solids. Ben, which one of these is correct? Do solids keep the shape of their container or do they keep their own shape?
They keep their own shape.
Very good, Ben. They keep their own shape. All right, liquids. Pony, can you please read for liquids?
Liquid keeps the shape of its container.
Very good. All right, and gases have no shape. Excellent work, everybody. Next one. Go ahead and draw. Read carefully. Read carefully, okay? I see some disagreement. What about gases?
Solids.
All right.
The shape if they are moved.
It
Liquid.
seems this is the only disagreement, so I'll erase those. Solids. Ah, interesting. Who haven't we heard from in a while?
Question.
Yes, what is your question?
Why do liquids keep their shape if they are moved?
That's what I'm wondering as well. Tiger, we haven't heard from you yet.
And why
Tiger,
do
can you
solids
read the one for solid?
keep their shape if they are moved?
Yes. Guys, everyone pick up a solid. Pick up a solid on your desk and move it. Is it changing shape?
No.
No, this is still the same shape. Do, 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 do. If I pour this water into this cup, will the water change shape?
Yes.
Yes. So, let's try this again. Everyone, go ahead and draw one more time. Thank you, much better. Does everyone understand this? Okay, let's try the next one.
Parody.
Go ahead and draw. Read carefully. Oh no, we have a lot of disagreements. Okay, I'll draw the lines where I see them. Excellent. Solids cannot change unless it's cut or broken. Gases will float to the shape of its container, then stop. Liquids will move and change its shape on their own. Not quite. Liquids will flow to the shape of their container, then stop. My water is just here. Gases will move and change shape on its own. If I blow into my cup, does the air stay in the cup? What do you think? If I blow in my cup, does the air stay in the cup? Everybody.
No.
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 No, yes.
Excellent. No. The gases will move and change on their own. Solids don't change unless you cut them. Gases will move and change its own shape. Liquids will flow and take the shape of their container. This is a little difficult, huh? Let's skip this one. Learn a new property, volume. Everybody unmute and say volume.
Volume.
Very good, volume. Who can read that first paragraph for us? How about Robert? Go ahead, Robert, first paragraph.
We measure liquid by volume. The volume of a liquid is the amount of space it takes up.
Excellent. So far we have mass, which we measure in kilograms or grams. We have length that we can measure in centimeters or meters. And now we have volume. What can we measure volume in? Does anyone know? We can use milliliters or liters. You guys have seen these words before, right? Milliliters or liters. So volume is how much space a liquid takes up. Everyone, go ahead and read this. First, what Robert just read. 1, 2, 3. Very good. So maybe this bottle has 100 milliliters of liquid, and this cup can hold 50 milliliters of liquid. It's how much space the liquid takes up. Can I please have Lion and Alex and Lily, the three of you, please read this bubble right here. Alex, Lily,
Different shape. The volume liquid is the same.
excellent. Great reading, you three. So, Potato, are the glasses the same shape or are they different shapes?
Different shape.
One
is tall and one is wider.
Excellent job. Is the volume the same or different? The volume of the liquid. Tom, is the volume of the liquid the same or different?
Different.
The volume of the liquid is different. There's different amounts of liquid.
The same.
The same. Let's say this one is 30 milliliters of liquid. This one is also 30 milliliters of liquid. It's just that the shape has changed, but the amount of liquid is the same. So, let's do an example. Could you measure how much ketchup is in this small bowl? If we could measure how much ketchup is in this small bowl. We can measure the amount. It could be 50 milliliters, a liter, a gallon. Gallon is a volume used in America, but not in the rest of the world. So don't worry about gallon. In America, we use cups and gallons. Everywhere else, they use milliliters and liters. So, how much ketchup do you think is here? Who could give me a number? How much do you think is there? Any number works. Leo, go ahead. How much ketchup do you think is here?
I think it's 49 milliliter.
Very good. Okay, let's say that. The liquid ketchup is 49 milliliters. Let's go with that. Toy Ayn, can you please read the yellow box for me?
Yes. If I change the container, does the amount of liquid change?
What do you think, Toy Ayn? If I change the container, will the amount of liquid change?
I think yes.
Yes, so if I put this ketchup in a different container, I will have a different amount of ketchup. Let's say I put the ketchup in a tall glass like this. Toy Ayn, will I have the same amount of ketchup or a different amount of ketchup?
Different.
Different, but the ketchup's the same, right? I put all of this ketchup into this container. Does my amount of ketchup change or does it stay the same? Lion, what do you think? Will my amount of ketchup change or stay the same?
I think the same.
I think the same.
So if I have 50 milliliters of ketchup here, Lion, how much ketchup will I have in my new container?
Still the same as the first one.
Excellent. This will also have 50 milliliters of ketchup. It will be the same volume, so it'll take up the same amount of space, but it will have a different what? Casper?
Shape.
Good job, Casper. Same volume, different shape. They're both 50 milliliters. Go ahead, what's your question?
Do we change size?
Nope, the size is the same. The size is volume. Volume is how much space it takes up. So both times the size is the same, 50 milliliters. It's just a different shape because the container is a different shape.
Everybody read this. 1, 2, 3.
The amount of liquid stays the same.
Good. The liquid stays the same. It has a fixed volume. Most adults get a fixed pay, the same money every month. You might get a fixed breakfast, the same breakfast every morning. Anyone else have something fixed in their life? Anyone else think of something that is fixed? How about Tiger? Can you think of something that is fixed? Or John, can you think of something that is fixed? Something that stays the same every day or every month?
A brick.
A brick has a fixed shape. The shape of the brick does not change. Excellent. I have something that's fixed. I have a coffee every morning. That is a fixed part of my routine. It never changes. Every morning I drink a coffee. So this liquid has a fixed volume. The volume does not change. Is the shape of a liquid fixed? John, is the shape of a liquid fixed or does it change? The shape.
The shape of the liquid is fixed.
It is fixed. It's always the same. Water is always the same shape?
No.
No. So say your sentence again.
The shape of a liquid is not fixed.
Is not fixed. It can change. The ketchup in a new container will change its shape. So it is not fixed. The shape of a liquid is not fixed. It can change. The volume is fixed. So everyone, unmute and tell me, are these the same shape?
Yes. No.
Are these the same shape? No. Do you think, are these the same volume?
No.
Yes.
Yeah.
Yes. The volume is fixed. It stays the same. They have the same amount. The shape is not fixed. It can change. Everyone, please read this. Ready? 1, 2, 3. Very good. Excellent work, everybody. All right, let's take a quick look at how mass and volume can help us classify matter.
Matter is something that takes up space. Now, you might be wondering why they all look so different if they are made of the same thing. But the truth is that everything around you is made of matter, just in different shapes and forms. Matter is made of tiny particles called atoms. Matter can be grouped into 3 main states: solid, liquid, or gas. To figure out which state of matter something is in, we need to examine its properties. A property is the way that something is that we can measure. The physical properties we will look at to determine state of matter are shape, mass, and volume.
All right, so here on our volume, you can see here, we have 50 milliliters, 200 milliliters, 300 milliliters, how much space the liquid takes up. And here, this is not a balance. Who remembers what it is called when we can get the actual weight in grams or kilograms? What tool is this? It's not a balance. What tool is this?
A scale.
Very good. Okay, 1 point on Class Dojo for Casper. This is a scale. to measure mass. A balance compares. A scale measures.
Mass is the amount of matter in an object. Volume is how much space that matter takes up. Solids are easy to recognize. Rocks, apples, pencils, and plants are all examples of solid objects. A solid object has a definite shape that doesn't change when you move it or put it in a container. They also have a consistent mass and volume.
The shape, the mass, the volume are all fixed. They do not change. It's the same shape, it weighs the same, and it takes up the same amount of space.
This is because the atoms in a solid object are packed closely together.
See, even in a container, it still keeps its shape. It has a fixed shape.
They do not move around. A solid will change shape only if forced. For instance, if it is broken or
Alex, eyes on the
smashed.
screen.
If you look around, you can find many examples of solid objects. Liquid is the next state of matter. Liquids have a definite volume and mass, but they do not have a definite shape.
So, everyone, this time please say fixed mass, fixed volume, not a fixed shape. Go ahead.
Fixed
mass.
Very good. So liquids weigh the same and they have a fixed volume. This will always be, let's say, 75 milliliters.
The atoms in liquid are still close together, but unlike the atoms in a solid, they can move around. This allows the matter in a liquid to flow. Because liquids don't have their own shape, they take their shape from their containers. The same amount of liquid may look very different in a glass and spilled on the floor. You can find examples of liquids around you too. Water, milk, and juice are just some of the liquids you might find. The third state of matter is gas. Gases have a definite mass, but they do not have a definite shape or volume. Like liquids, gases take the shape of their containers.
So this one only has a fixed mass. It always weighs the same, but no fixed volume and no fixed shape. These two things change.
Unlike liquids, gases will spread out to completely fill the container they are in. This is because the atom.
So if we look here, if this were a liquid, it would all be on the bottom. But because it's a gas, like when I blow into my cup, they keep spreading. They do not keep their shape. They do not take the shape of they fill the whole container up. If the container was this big, all the gas would be in it. If the container was this big, it would still have the same amount of gas. And if it's this big, it still has the same amount of gas. Okay? So,
Gas are farther.
any questions about this? Today we learned, everyone read this, 1, 2, 3. Very good. Excellent work, everybody.
Let's go over to Class Dojo. First of all, our point for Casper for remembering the word scale. Oh, I'm still on 2E8. Sorry, guys. 1 second. Here we go. All right, 1 point for Casper. Here we are. On task for paying attention. Now, STAR students today, a lot of people did a very, very good job today. I'm going to say 1 point for Pony. Working hard. 1 point for Riku. Very nice work today. Okay, Mia. Tomorrow I'll pick new star students.
Lastly is your homework. Please pay close attention. This is a project. Your homework tonight is just to draw a picture. That's it. Draw a picture of an object you can make at home using at least 2 different states of matter. So out of a solid, a liquid, and a gas, you need to pick at least 2. Solid and liquid, liquid and gas and solid. You can pick all 3 if you want, but you need at least 2. What objects in your house are solids? Try and recycle if you can. You can use plastic bottles, pencils, paper, cardboard, toys, Legos, bowls, but try and recycle if you can. What objects in your house are liquids and how could you use them? You can use water bottles, you can use bubbles, you can use milk, ketchup, you can use markers, because remember, the color in markers is liquid. What did you say, Potato?
Soap.
Soap, excellent, yeah. Use some soap.
Juice.
Okay. Juice. What objects in your house are gases or could hold gases? An empty water bottle has gas in it. A balloon. Bubbles if you're using soap.
Can I make a cup of milk because it is a liquid and solid?
Technically you can, but that sounds pretty boring. So you can use these things to invent something or solve a problem like an engineer. You could do an experiment with soap, milk. There's a really fun experiment with soap and milk and food coloring. Let's do questions at the end, okay? There's a really fun experiment with soap, milk, and food coloring. You could build a toy, something to play with, something to help you classify things at home, something for your pet. You can draw a picture of anything you want. Here are some examples. This is an experiment with hot water and air. Here you use air, wind. This is her building something. Here you use all 3. Plants are solid, liquid water, and air. Here you use food coloring and milk and soap for an experiment. Here they're building with Legos. Here they are making art with solids and liquids. Just remember, make sure you can actually make this because you will be making this drawing over the weekend. So you are drawing a plan. So, bye everybody. If you have a question, stay on and I'll answer your question. Bye-bye.